Welcome to Chemistry World. Today we will see valence bond theory. This is the one of the important theory in chemistry. So it is based on atomic orbitals. Second one, electronegative configuration. Third one, overlapping of atomic orbitals. Fourth one, hybridization. See here, example, hydrogen molecule H2. This is the H A hydrogen, this is the Hb hydrogen. So both are as nucleus. So electron around the at 1s orbitals. See below, the force of attraction at H2 molecule. See below, this is the force of attraction. Tricks. See that this is the HA atom, this is the HB atom. See, nucleus A, this is the nucleus HA atom, electron A atom. This is the nucleus HA and electron A. So this nucleus is proton, these electrons both are attractive force. Next, nucleus B, this is the nucleus B or HB. EB, this is the HB and EB. So this nucleus and this electron both are attractive. Next, nucleus A, this nucleus A, so electron B, EB, this is the EB, these both are attractive. This nucleus, this electron both are attractive. Next, nucleus B, this is the nucleus B and the electron A, this is the electron A. These both are attractive. This is the force of attraction of H2 molecule. See below, here N is nucleus, E is electron. For easy understanding, see the diagram. I written the diagram, this diagram myself. See, for simple understanding, this nucleus attract this electron, this nucleus attracted this electron. At the same time, this nucleus attract this electron, and this nucleus attract this electron. This is the HA atom, this is the HB atom. This is the force of attraction diagram. Next, force of repulsion. What? See below. This is the nucleus for hydrogen A atom, this is the nucleus for hydrogen B atom. See here Na Nb, here Na Nb, so this both are repulsive because both are nucleus. Next Ea Eb, these both are repulsive because both are electron. See below. This electron both are repel, this nucleus both are repel. So during bond formation, the force of attraction greater than force of repulsion, because we seen the above the diagram, that is the main causes. Here see, this is the main causes for all bonding formation, because if repulsive force and attractive force both are same, so if both are same, molecules does not form in the universe. Keep in mind. Here see below, the force of attraction greater than force of repulsion. All bond formation occurs by maximum force of attraction between the two atoms. Here maximum force is attractive. Here attraction force is more than repulsive force, so force of attraction is winner and force of repulsion is lesser. We see potential energy curve for H2 molecule. See the diagram. It tells about internuclear distance and energy changes when bond formation between the two atoms. See below. This is the H2 molecule. See the diagram. This is the y-axis, this is x-axis. 0, 1, 2, 3, 4, 5. If two hydrogen atom coming to bond formation, see here, this is the maximum distance, and going to this is the middle distance, this is the very less or minimum distance here possible for bond formation. See the diagram. This is the complete overlapping. This is not complete overlapping. This is also not complete formation. If both the atoms comes together, this is the maximum distance. This is the middle. This is the very less or very low distance. So here is possible for bond formation or complete overlapping. See below, this bond formation we should spend some amount of energy. This energy is 473.2 kilojoule per mole here energy is decreasing bottom to top. So when the two atoms at bond formation at minimum distance, this radius or distance is 74 picometer or is radius. This is the internuclear distance. This is called internuclear distance because this is going to negative value. See, so this H2 atom is more stable because it is going to negative value. So negative value means very less energy. Okay, please keep it in mind. If comes positive values, that is unstable molecule and higher energy. Keep it in mind. Next, here both H2 atom has more distance at 1. See above the diagram. This is the place, or this is the place 1, this is the 2, this is the 3. Please see the diagram. We can move below at maximum distance at 1. Both H2 atom has more distance at 1. When gradually moving between them, internuclear distance decreasing at 3. So the 3 is the very less internuclear distance at exactly 74 picometer. The bond is formed. At y-axis energy level going to negative or minimum below the 0, so internuclear distance going to decreasing. So both H2 atom combined together at 74, exactly 74 picometer distance, and release the energy at, this is the release the energy at 437.8 kilojoule per mole. This is going to attain exothermic process and going to negative value. This value is 437.8 kilojoule per mole. It is called bond dissociation energy or enthalpy. Enthalpy means heat. So we can like energy or enthalpy. Next, bond dissociation enthalpy is if we again break the two hydrogen atom, we can give this energy, this 437.8 kilojoule per mole. Suppose if we again break the two hydrogen atom, so we need spend this amount of energy. Next, bond association. See the definition for a bond association. It means the molecules involved and bond formation. This is called bond association. Next, bond dissociation. If we can break the molecule or two separate atom, we need required some amount of energy. This is called bond dissociation. Next, force of attraction and force of repulsion for H2 atom or H3 molecule. see the force of the attraction. So the force of the attraction is here +2 minus or nucleus to electron, again electron to nucleus, again nucleus to electron. So here all are as attraction force, but if we see at repulsive force, see below, this is the 4 possible here, this here only 2 possible, this electron only repulsive, this nucleus only repulsive, but above the diagram 4 possibility, here 2 possibility. So this is a attraction force is more, repulsive more force is less. See below, overlapping of atomic orbitals. See, it is 2 types, positive overlap and negative overlap. First we can see positive overlap, pp orbitals at positive overlap. See, the positive overlap denoted spin in opposite direction, it is favorable for bonding. The spin in opposite direction, it is a main important terms, it is the favorable for bond formation. The pp orbitals means if 2 atoms comes for overlapping in its orbitals. We know already pp orbitals. See below the diagram for this. This is the 2 orbitals. For example, 2 hydrogen atom, this 1 hydrogen atom orbital, this 1 hydrogen atom orbitals combined together. This is the positive, this is the positive. This both positive denoted the favorable condition, bond favorable condition. This is not plus sign or minus sign, please note it. This is not denoted any sign plus or minus, this is the favorable means possible. See carefully next. This portion is very important, please. If you don't, if you any confusion, see again the video. See carefully below. Here bond formation occurs between the both positive lobes. Between the both positive lobes, this is the lobes, 1 lobes, 2 lobes, 3 lobes, 4 lobes. This is both positive lobes. So this both positive lobe denoted bond formation favorable. This is not any positive or negative value. Please keep it in mind. Next, negative overlap, pp orbitals. Negative overlap denoted spin in same direction. This is the very important term. At a positive overlap, spin in opposite direction. If negative overlap, spin in same direction, it is unfavorable for bonding. Unfavorable means impossible for bond formation. If bond formation occurs between the positive and negative lobe, it is p orbitals. This is called unfavorable overlap. See, this is the, sorry, this is not minus sign, I written mistakenly. This is the positive, this is the negative, so both are not same, so unfavorable. Bond does not form in this case. So this both positive and negative sign denoted bond unfavorable. Please keep it in mind, it is very important. Next, sigma bond formation. See, that is sigma bond formation. This is the positive overlap, pp orbitals. This is the negative overlap at pp orbitals. So we know that pp orbitals only combine at pz axis. This is the sigma bond, pz axis. See, this both lobe is positive plus sign, or it is called head on overlapping. These both lobe, one positive, one negative. So this is also head on overlapping, but not favorable. This is not bond formation. So positive overlap sp orbitals. Next, negative overlap sp orbitals. See, sp orbitals. This is the sp orbitals. Same thing here, pz axis and pz axis. This is the bond favorable, sigma bond. This is the bond unfavorable. Let's see again. Now we are going to move pi bond formation. First we seen that sigma bond formation. This is the pi bond formation. Here also positive overlap pp orbitals, and negative overlap pp orbital. See the diagram. These both lobe sideway overlapping. This is this type of lobes sideway overlapping. This is occurs only pi bond, but head on overlapping occurs in sigma bond. This is the px, this is the px axis, this is z axis. So both are positive, positive. So this is bond formation are favorable. See here, pi bond. See here, this plus minus minus plus px px. This is unfavorable at a z axis. Please don't forget the axis. Next, see, next these both are C at, this is the x px, this is the py, This both are positive sign, so this is favorable. These both are negative positive sign, so unfavorable. Z axis, this is a P Y, this is the P Y. Here P X, P X axis. See below. Usually sigma bonds are strong bond due to head-on overlapping. Head-on overlapping means both orbitals meet at the same axis because this is strong bond, or it is called axial overlapping or head-on overlapping. Next, usually pi bond or weak bond due to sideway overlapping. PZ orbitals only created sigma bonds, not pi bond. See, PZ, so note this point, PZ orbitals only created sigma bond, not pi bond, because axial overlapping or head-on overlapping. Next, see, Px and Py orbitals only created pi bonds because side wave overlapping. Next, axial position. So this is the x-axis, not, sorry, this is the z-axis, not x-axis, because we can see this at 3-dimensional. So this is the x-axis. This is the, sorry, this is the z-axis, this is the x-axis. See here, here x-axis perpendicular for z-axis. Next, here because atoms are spherical, that is why we written like this. Next, this is the z-axis, this is the x, this is y. This y also perpendicular for z-axis. So we cannot draw exactly. That is why this is also, keep it in mind, this is also perpendicular for z-axis. X-axis also perpendicular for z-axis. See here, here x-axis perpendicular for z and y-axis. The x-axis perpendicular for, here all are perpendicular for between x, y, z, because this is a spherical shape. We know atoms are spherical. Next, geometrical shapes. VSEPA theory not given exact explanation about the molecule geometry, but valence bond theory gives detailed explanation about the molecule geometry. Now let's see. For example, methane, CH4, we know that carbon valence is, electron configuration is 1s2, 2s2, 2p2. This is the valence electron, 2s2 and 2p2, 4 valence electron. See, So we know that carbon always going to at the center, hydrogen always going to at outer. See this this all 4 hydrogen as at 109.5 degree each side. So both all are as equally force. This molecular geometry shape is tetrahedral. See below. Orbital diagram for carbon. This is the 2s orbital. This is the px and the py, pz orbitals. Carbon has 2 electrons at 2s orbitals. Here one orbital, here 1 electron, here 1 electron. This is the empty orbitals. So this is the ground state, this is the excited state. This electron going to promoting in these parts. See below. This is called electron promoting. See below. After promoting the carbon atom as 1 electron, 1 electron, 1 electron, all are unpaired electron. Now see below. Hydrogen, hydrogen, hydrogen. Now for hydrogen donated 1 electron for each carbon orbitals. See below. Here 4 unpaired electron of the hydrogen atoms donating the 1 electron for each carbon atom and bond formation, involving the bond formation. Here all hydrogen atom donating the 1 electron for each carbon. So now all are paired. Here 2 electron, here 2 electron, here 2, here 2. Next. Another example. Let's see some example for NH3. Ammonia. Ammonia is the band angle is 107 degree. Shape is, geometrical shape is pyramidal. See here, this is the nitrogen, this is the 3 hydrogen. We know that nitrogen makes triple bond, but it has 1 lone pair electron. Here 1 lone pair electron, so small bend, because this hydrogen also has electrons. So this electron, these hydrogen electrons both are repel. So the band angle is slightly bent, but at H2O, see at H2O water molecule, band angle is 104 degree. See between the difference. Here 2 lone pair electron, so here repulsive force is more than ammonia, so 104 degree. Here more bent than NH3 due to 2 lone pair electron, because more repulsive force. please subscribe the channel and share it with your friends. More videos on the way. I am making more videos about the all organic, inorganic and physical chemistry. Please subscribe the channel. Have a nice day.